I would like to welcome you to our runZero webinar, Unknown Assets are the Achilles heel of effective cyber defense and zero trust. At this time, I would like to introduce our speakers for today's presentation. H.D. Moore, CEO at runZero, Pete Allen, Federal BD at runZero, and Derek Burke, Federal SE at runZero. With that, I'd like to turn it over to our presenters of the day. HD, Pete, and Derek, the floor is all yours.
Thank you, Lauren. Appreciate the introductions. And thank you, everybody, for taking the time today to hear the runZero perspective on how unknown assets are the Achilles heel of an effective cyber defense and zero trust. You can advance the slides. Thank you. You can go past those since we did the introductions. So runZero is a cyber asset attack surface management solution for IT, OT, and IoT devices. runZero allows organizations to see and secure every asset connected to the network, including unknowns. And with 500 plus customers ranging across customer segments of very small, of customers that have 1,000 assets and fewer, all the way up to Fortune 100 customers with 1 million plus assets, as well as runZero having 18,000 plus community users leveraging our free edition. And not only is the runZero customer base continuing to grow, the awards and accolades that runZero is receiving for our innovative platform continues to grow as well, including the Gartner Peer Insights Customer Choice Award for 2024, the Cyber 60 from Fortune Award, as well as the Cybersecurity Excellence Awards for both the Best Cybersecurity Startup as well as the Best Cybersecurity Asset Management Solution. And those are just some of the accolades that runZero has received. And without further ado, I'm going to pass the ball to HD to review our agenda for the day and then walk us through the presentation materials.
Great, thanks.
Thanks, HD. And what I did want to mention to everybody is please answer all the polling questions as they pop up on your screen. Thanks, HD. All yours.
I appreciate it. Thanks. So today we want to chat about one, kind of what we do, who we are, why we care, why we're talking about this stuff. Two, we want to dig into how the world has changed and then also how it's not changed over the last 20-something years when it relates to security. We want to dive into our kind of hybrid approach to security, talking about how you do rapid network discovery, really quick exposure identification, and 0-hour response for emerging threats. After that, we're going to dig a little bit into how to satisfy your key compliance and zero trust requirements, and then how to do quick and easy deployments using the runZero platform. Following that, of course, we'll have Q&A, and feel free to ask questions anytime you like. We'll either answer them all at the end, or if there's an opportunity to answer them mid-demo, or while we're covering some other content, we can cover them then as well. With that, we'll get started. So first off, why? Why do we have a thing called runZero? So my background is coming from the pen testing and exploit development side. I got started in the late 90s working on exploits at the time, working for US Air Force in San Antonio through CSE, building all kinds of fun tools for doing terrible things. My background from that point on was doing consulting work, pen test work. I created this thing called Metasploit, ran that for about 15 years. And we really focused on helping folks, test the security of their systems, usually in the most offensive way possible, in terms of actually trying to break in, actually trying to get a shell, actually trying to bypass. What we found, though, is that over the years, anytime I was working with an organization that cared a whole lot about security, if you've got a really solid security team, you're using 15 different tools, you're managing all your stuff, you've really got a good beat on all your things. If you know about something, you probably have a good controls around it. The challenge, though, of course, is where you don't know about stuff. Where some of my consulting customers kept running into problems is where we would find an asset that wasn't even on the radar. It wasn't part of vulnerability management. It didn't have an EDR agent. It was nowhere in their scope of risk. It wasn't part of the spreadsheet IT handed them. And so when us as the attackers found that asset, we could break in, take over. And it was a very long time before they noticed that we're even in the environment, let alone could figure out how we got in. And that's been a constant. the last 20 years, it's always the small stuff. It's always those little things in the corner you forget about that can ratchet up and to become these bigger events. It could be the DSL modem sitting in the closet, in the telco closet, someone forgot about. It could be the backup ATM line. It could be your building access control system. Can't tell you the number of times you found, broken network management, broken network segmentation, overlaid VLANs, all being things that cause, eventually catastrophic problems when a threat actor figures it out. This stuff is all really easily missed by vuln management too. Your vuln scanner can't tell you that your network is misconfigured. It may be able to tell you that if you know where to point it, but in generally, like, you're not going to be able to find stuff just doing kind of a blind vuln scan. At the same time, your endpoint protection is also enough. You can't just install an agent on all your managed devices and expect to see everything, because your managed devices are actually a small portion of the whole. Even your NDRs, even your password detection tools that are monitoring network traffic, they're also blind to a lot of areas of the network. They really struggle to see east and west traffic at some levels. When you have lots of small geographic regions, it's really difficult to deploy sensors in all those regions to bring the traffic back. And of course, the response time is critical. If there's a new emerging threat and whatever the fancy product of the day is, like, you need to respond that hour, or you're going to get an extortion letter the next hour. So how does all this apply into zero trust? The short version is that without a solid asset inventory and knowledge of your environment, you really can't build a foundation for zero trust. You just can't get there. So zero trust efforts typically fall into three buckets: either help you maintain control over existing endpoints and servers. Those tend to be EDR agents, other times the security controls that run on device. Centralizing your authentication authorization to make sure that all accesses to applications, to data sources are going through the right levels of control and monitoring. And lastly, for things you can't control, segmenting them off into different areas so that they can't talk to things, they can't reach data that otherwise be sensitive. So those are kind of the three big buckets we've used over the years to drive zero trust initiatives. And typically the way you do that is you roll out EDR and VM for your managed assets. You roll out single sign-on overlay networks, things like authenticated proxies for all your applications. And everything else you just put into different segments and hope it can't talk to each other, and you assume that that's good enough for now, because there's not much else you can do. So the challenge, of course, is without the full visibility, you can't really do that. You can't really move the needle forward with zero trust. What we found is our customers at runZero have found 25% more stuff than when they started, before they used our product or worked with their team. It tends to be all the stuff that you don't really think about very much on the IT side, and you really hope doesn't exist on the security side. These tend to be your vendor managed appliances and equipment. It could be a storage appliance. It could be something that's managed by a third-party contractor. All your OT, HVAC, IoT stuff, all the things that you really can't install like a CrowdStrike agent on. There's no way for you to really get visibility into that system. Then, of course, you've got all your shadow IT and all your forgotten networks. For orgs that have had consolidation, or they've been, squished together over time, or, sprawled out over time, you often have multiple different Active Directory domains. You often have lots of systems that are still in the old domain, haven't migrated fully over, and just lots of stuff out there that's not really part of, it's not really on your dashboard of systems that you monitor or control. The problem, though, is that 25% that you don't know about is often the most dangerous. It's often the machines that don't have any security controls. They may not even have an antivirus installed. It could be outside of your vuln management scan scope because you don't know about the range. It could have a firewall preventing you from scanning it from one direction, but it's still accessible from another. These tend to be things that are just unmanaged, forgotten, and generally misconfigured. And of course, these often tend to be unpatched and running really obsolete software as well, because there's no one to keep an eye on it. There's no one who really knows that they're there. And at the same time, they still are tied to critical functions and data. So even things like, your kind of boring door access control system, like, yeah, it's really important because without it, people can walk into your building or you can't get into your building. But at the same time, it's not really on your radar as the most critical IT system that you have in your environment. And so that's usually the contrast you're working with, is that the things that are generally off your radar are often the ones that are most important for security controls. So I'm going to dig a little bit into like how the world's changed. So I've been doing this for about 25 years, and it's gone from, everyone just kind of being, either inside the network or outside the network. And I used to call it the hard candy shell and the soft chewy inside is the term we used back in the 90s and early 2000s. These days is a lot different, right? We've got segmentation, we've got controls, all kinds of things all over the place. The last 4 years alone, I've seen probably the biggest rate of change in IT and security, bar none. The huge push to work from home to support folks during the COVID lockdowns, all the migrations to cloud, the huge spike in containerization, the use of virtual desktops these days to reduce how many PCs you actually have to deploy, and IoT everywhere. I mean, you go to smart everything: a smart shower head, a smart TV, a smart toilet, and half the stuff is network connected. These things aren't just limited to home environments either. We see IoT, and especially, the smart displays, the smart kiosks, those are all over corporate environments all over the place. They're not being restricted to just consumer environments. All your processes and tooling are really struggling to keep up though. And the challenge is if you're in the middle of migrating to a cloud, well, now you have twice as much stuff. You've got the stuff that's on-prem that you're trying to migrate. You've got your kind of nascent cloud environment that you're trying to build out. In the meantime, the middle state's really messy and dangerous. You've got systems that are exposed that shouldn't be. You've got probably Apple set up that you are just supposed to be temporary. And what worked before for keeping track of security probably doesn't work anymore. There's a great report by the NSTAC organization, National Security Telecommunications Advisory Council, and they gave up. They said in 2022 that IT and OT will be on the same network no matter what. They've just considered this to be a given. You can no longer separate your ICS systems from your IT long term. Their take is that these networks will converge whether you like it or not. There'll never be a hard gap between these two environments. There'll also be some sort of gateways and filters and protection, but they will be connected in some way going forward. We looked at a broad sample of all runZero observed ICS assets in our backend, and over 7% were still directly connected to the internet. And that's not a huge number, but these are really important. These are systems that you absolutely generally do not want to have connection to the internet. And what we're seeing over time is the number of overall exposed ICS systems in the last 5 years really hasn't changed very much. It shot up abruptly about 5 years ago, and it's kind of stayed level ever since. While there has been some reduction in how many machines in the US geography have been exposed, we've seen a much wider exposure across the rest of the world to make up for the difference. And even in large US organizations, it's really common to have your PLCs, your data loggers, your building controller, your power controllers externally exposed occasionally. So when you think about like what's on your network, what's in your environment, we like to think about it as doing 3 different buckets. You've got what we call monitored devices, things you can actually directly manage, your laptop servers, routers, switches, things that are like, they've got some kind of control. You can log into them, you can install things, you can pull telemetry off of them. You can generally keep a good handle on what's going on with those systems. Then you've got devices that are a little bit less visible. You've got your smart TVs, your projectors, your WAPs, your printers, all the other stuff out there that, yeah, you kind of have some control on it. You can at least tell it what IP it has and put it in a particular network, but you can't really put an AV on it. You can't really put any other kind of EDR on it. You're kind of dependent on the rest of your tooling outside the device to keep track of it. And lastly, we call dark matter. These are systems that you just generally don't show up anywhere else. There may be an IP address in the network that has an IP but doesn't have any other services open, like a typical thermostat where it's just connecting out to the cloud, doesn't have any local connectivity. It could be something like your aquarium fish tank. There's lots of these kind of like really low, low complexity, low processing power embedded devices that are still on the network that are really hard to control and just generally don't have a lot of visibility into. They often run firmware that's many years out of date, and they're not part of anyone else's map of what is in your security state. So how much do these devices folks actually have? Well, typically, if you look at the machines that you have got great control over, things that you can install an endpoint agent on, things you can actually monitor and do vuln scanning on, they tend to be about 35% total. The other 60% tends to be everything else. Your printers, your scanners, your oddball devices, your HVAC, your IT, your IoT, all the other stuff out there actually makes up almost 2/3 of your entire environment. And if you say that's not right, my environment, 99% of all our machines are monitored, well, you're probably missing the other 2/3. And that's actually really common. It's really common for us to see folks that the IT and the security teams agree that our estate is X and it's on these networks, on these VLANs, on the system, but they don't know what the networking team is doing. And they don't know what their ISP has done. They don't know what the backhaul looks like. They don't know what their building control systems have set up. It's all that other stuff that really comes back to bite you on the security side. In the last 1.5 years, we've seen a huge wave of increases to attacks on edge-facing equipment. And if you go back about 5 years ago, phishing was basically the most common way to any enterprise. You just find somebody who's willing to open a link, you attack the endpoint, you get it through the endpoint, and off you go. We've done a good enough job at this point with protecting endpoint systems, with adding email filtering, with having great web proxies that I would say we've licked the malware problem, but we've gotten a lot better at preventing people from getting in through the front door through effectively email and directly targeting our employees. Instead, what folks are doing instead are going after all your edge-facing equipments. These are your VPN gateways, your file transfer appliances, your collaboration servers. The challenge is you can't really firewall it off. Kind of a funny statement last week was there's a vulnerability in the Cisco product, and they said, well, there's no way to disable this functionality in your Cisco product while still having a functional VPN, in your checkpoint product, but you can put another checkpoint firewall in front of that firewall to protect it. And it's like, well, how many firewalls do you need at this point? You can't really put a firewall in front of your firewall. And oftentimes we're seeing remotely exploited zero-day in security appliances, in your SL VPNs, in your remote desktop platforms, in your VDI platforms. These are all really high value targets, and they have access to the network as well as the data. A lot of times you see these things, people start to hear about them on Thursday afternoon. it becomes a full raging dumpster fire by Friday afternoon, and there's no patch available. And the vendor says, have a great weekend, see you next week. And then you've got an entire weekend of rapid exploitation happening. And hopefully the vendor eventually has a patch, but at that point, they also have to provide you an IOC to look for signs of being compromised. So lots of examples of that. I can give you a few. The most recent Palo Alto vulnerability in SLVPN endpoint, I think, was also disclosed on like a Thursday or Friday, and there wasn't a patch available until the following week. So literally every customer who had to make a choice. Do I turn off my VPN for the weekend in a few days, or do I risk being exploited by unknown actors over the weekend with almost no way to mitigate it in the meantime? That same choice was presented to customers who are using the Cisco iOS XE firmwares for the web management interfaces. Your options are either turn off web management, which may be the only way you have access to that device at the particular time, or wait up to 2 weeks for the patch to come out. In the case of the Cisco iOS XE vulnerability, by the time the vendor had even notified customers that the vulnerability existed, they also provided IOCs because at least 10,000 had already been backdoored. By the time the patch became available to customers, over 50,000 machines were estimated to have been backdoored. And again, this stuff always drops on a Friday. So we're seeing the rapid exploitation of edge devices really picking up, and this is kind of changing how quickly defenders have to respond to get ahead of these attacks. So we also talk about how the world hasn't changed. So those are all the things in the meantime and the recent years that have really kind of pushed us forward, and they're kind of changing the landscape for defenders. But a lot of things really haven't changed. We're still seeing kind of a slow scan and patch cycle that limits our ability as defenders to move quickly. If your vulnerability scan vendor creates a plugin to detect something, great. Well, you have to go wait for them to build that plugin, apply that plugin, wait for your scan window, run your scan, look at the results, then you can respond. Well, that could be a week, that could be 2 weeks at certain companies, depending on what your windows look like. And at that point, you've already been compromised. You've already have an exposure letter, extortion letter sitting in your desk. We've also seen security controls really struggle with containment. AV, EDR has been pushing as hard as it can to reduce kind of the blast radius of attacks, but it's still not perfect, right? We're also seeing cases where segmentation is completely broken, where everything we've done to put all the bad, untrusted devices into their own little buckets, that's coming back to bite us because there's so many of those devices sharing the same space, and there's different ways to get out of that segmentation. Basically, subverts the whole process of segmentation itself. So I'm going to talk a little bit about, if you go back to what vulnerability management looked like in 1999, here's some graphs from reports of the day. You may recognize some of these products if you've been around for a while: CyberCop, ISS Scanner, things like that. And you have, vulnerabilities by severity. You've got breakdown of OS by host by operating system, things like that. All kinds of fun OSs. Cisco, FreeBSD, lots of like SGI, Solaris, all the old school stuff, Windows 95. Now, fast forward to 2024, and you think that, the current crop of vulnerability management products would probably be a little different. Well, ends up it's almost identical. We have the exact same graphs, the exact same measurements, exact same charts, and we're working the same way that we were 25 years ago. Now, in addition to vulnerability management kind of being the same old, what also is changed is how we go about finding vulnerabilities. Your typical vulnerability scanner in 2000, 1999, 2000, 2001, the majority of all the different checks it did on the network were unauthenticated. They were remote unauthenticated checks. They were from the perspective of an attacker trying to determine, is this machine exploitable? Is it vulnerable? And you see over time that pink bar here has been dropping and dropping and dropping. By the time you get to 2024, only a very small portion of all vulnerability checks are actually unauthenticated remote checks. And there's a bunch of reasons for it. What's interesting, though, is looking at the absolute values of that as well. So look at the absolute number of vulnerability checks that were being produced in 1999, 2000, 2001, et cetera. They're mostly remote. If you go all the way down to 2023 here in the beginning of 2024, it's actually about the same number. Like the absolute number of remote unauthenticated checks per year has not changed substantially in 25 years. At the same time, the number of total vulnerability checks for authenticated checks, of course, has ballooned up because every different Linux distribution, every different type of OS has its own authenticated checks that are very similar but overlap quite a lot. So vendors who are producing vulnerability management tools really haven't stepped up. They're producing the same number of remote vulnerability checks they were 25 years ago that they are in 2024. That's not helping us keep up with the remote exposures that we're seeing, especially with exploitation at the edge. Now, a lot of folks will say, great, well, I can't trust this thing, so I'm going to segment it. I'm going to put it into this different network, my guest network, my Wi-Fi network, whatever it is, and then it can't hurt anything else. It's off to the side. It's not going to cause any problems. The problem with that, of course, is it gets messy really quick, especially over time as you start adding more and more stuff to your segmented networks. It becomes difficult to really lock it down. So taking a very simple example, you've got your firewall, you've got your DMZ up here, you've got your corporate network that's wired, this bottom left square. Then you've got maybe your wireless guest network with a couple of printers on it, your laptops, your phones, things like that. So kind of standard 3-box network. Most networks are more complicated, but just to give you an idea of where to start, that's how a lot of folks think about their environment. You've got your trusted network, you're not really trusted DMZ, and you're definitely untrusted guest network, and they're all separate. The challenge though these days is almost everything can act as a router. So nearly every printer you can buy today has IP forwarding turned on, and it has multiple interfaces. That means that when you buy it from the store and you plug it in and you plug into Ethernet network, it also has a wireless interface, it also has a Bluetooth interface, and it's designed to route packets by default, which makes no sense whatsoever. Ends up a lot of different types of devices have IP forwarding turned on as well. It's really common for your brand new MacBook, for example, if you do ifconfig on the command line, you'll see like 17 different interfaces on a brand new machine. Like, what are all those things? Wireless display link, blue link, tunnel adapters, all kinds of stuff. Anytime you plug into any network anywhere, your machine also has a v6 address, usually a link local, but it's still a v6 address. And you can do all kinds of fun v6 attacks and routing attacks and man-in-the-middle attacks as a result. And lastly, with container hosts, like it's all the rage for developers to use Docker and other container environments to build their systems. They often don't realize that the way that your Docker networking works on your own machine as a workstation actually enables IP forwarding, and not just IP forwarding between your Docker interfaces, but between your wireless network and your Ethernet. So the challenge with all this is that with these devices all over the place, with multiple interfaces and routing enabled, effectively everything is a router, and your segmentation starts to fall apart really quickly. All it takes is one exposure, one missing link between two different networks, and your segmentation is no longer effective. So to give you an example of what that looks like, and the right side over here, we've got a wireless guest network, and we've got a printer, which may have Wi-Fi still enabled because someone replaced the previously broken one, plugged it in, and someone sitting in the parking lot connected to it via Wi-Fi, and from there they can route into the rest of the wireless network. Separately, you've got a machine over here in the corporate environment that may be plugged directly into an Ethernet port, and everything's fine and dandy, except it still has its Wi-Fi interface turned on, and the Wi-Fi is still associated with the network over here on the wireless network. I can tell you, like, the default behavior of both Windows and Mac right now is that if you are normally connected to a wireless network and you go plug into Ethernet, it'll route out by Ethernet by default, but it'll keep that connection to the wireless side. Effectively, you are a WAP, you are a wireless AP. Anybody who can reach your machine, and especially your machine is configured to route traffic, can now use your machine as a router to get into the other environment. And that's a really common failing. We see that all over the place. As you start scaling this out and look at a network of 100 employees, just 100 employees, it gets really complicated really quick. Your 6 degrees of Kevin Bacon here starts getting fantastically complicated. Almost any point of this environment can reach any other point without going in a straight line. Not everything has to go through your firewall, especially if you depend on things like NAC and port locking and MAC locks. Well, you can just ask the printer to route the traffic for you, and then it's using its layer 2 address, right? You can force a developer workstation or a server that happens to have IP routing turned on to route traffic for you instead that way. And as you scale this out to even a slightly bigger network, let's say 300 employees, the mess gets even bigger. It's really hard to untangle this stuff. There's literally no chance of you being able to successfully segment off any network from any other network with modern equipment. And we can do our best, but segmentation as a control strategy has been falling apart for a while. So with that, I'll hand off to Derek to talk about some ways to solve the challenge.
Thanks, HD. Yeah, so as HD was saying, the way that runZero addresses this challenge is really starting with that core premise that complete visibility of the connected landscape is a foundational requirement to not only an effective security posture, but by extension, implementing a zero trust architecture. And to that end, what runZero provides is a comprehensive and consolidated asset inventory that comprises all of those IT systems, IT infrastructure, your OT and ICS devices where those are found, as well as those IoT devices that are increasingly prevalent throughout our connected world today, right? And this isn't limited to just your on-prem infrastructure, but this accounts for the cloud infrastructure and those remote devices as well. And the way that runZero achieves this is utilizing an agentless approach that is comprised of 3 distinct techniques, that being active unauthenticated scanning, passive discovery, and API integrations to drive the outcomes that you see here on this slide. And then to kind of highlight some of those outcomes, again, with that consolidated inventory, and keeping in mind that this isn't just a kind of a combined approach, this is a continuous approach as well. So consistently scanning the environment, ingesting that passive information, reaching out to those security and IT tools that are already deployed in the environment to correlate that API integration data. We're having a consistently up-to-date and accurate inventory of what that attack surface looks like, which allows you to very quickly highlight things, make informed decisions, and assess things like the risk in the environment, prioritizing that risk. Also being able to, once identifying something that needs remediation, be able to see particularly who is responsible for those assets by tracking asset ownership and even assigning coverage goals and things of that nature so that you can track your initiatives over time to kind of get a metric on how successful in a given initiative you're actually being. Segmentation issues were another thing that were talked about here. But the other side of this is with this consistently updated and accurate inventory with all of these data points that you've already collected, it makes it extremely fast to be able to respond to things like new threat vectors, threat actors, and 0 days. By searching against the data points that are already in there, you can often identify quickly the assets that would be impacted by those potential vulnerabilities, even without having to perform any kind of rescan of the environment like you might typically have to with a vuln management solution once those new signatures are pushed out. And it extends beyond just the 0 days, right? We have end-of-life software, things that are no longer receiving security patches we need to remove from the network. Again, prioritizing vuln data, not just the things that are found natively within the platform, but ingesting the data from your VM solution so you can cross-reference that, but then also bring in the context of the fingerprinting that runZero provides through its discovery methods, which is going to provide a lot of contextual data around those devices, what they're doing on the network, what are they capable of, do they belong on the network? And with that in mind, a lot of this funnels back to being able to query across all of these data points. And runZero has a query library pre-constructed that allows you to very easily start to assess these things and get a baseline in the environment around sort of those different metrics, which we'll showcase in an upcoming demo here. So I also want to spend a little bit more time talking about that combined approach because this is a distinct differentiator from other similar solutions in the market when it comes to asset inventory, right? A lot of those are based on the idea of pulling in API integrations, but as we discussed, the API integrations, if you can query an API to a security control you already have in place, then fundamentally you have some knowledge that that asset exists. And it's those unmanaged assets that really tend to be the highest level of risk because they're unmonitored, unknown, and they could be bridging across networks and not even being realized in that case. So to that effect, that's where we bring in the active unauthenticated scanning technology. And this is a proprietary scan methodology designed by HD and the engineering team from the ground up to do two things and do two things extremely well. One, fundamentally, is fingerprint those devices, not just tell you that we found a device, but give very granular information about what that device is, so you can make those informed calls as to what function and does it have a business case on the network. But then the other side of this being also safely enumerating all of those devices, right? So not only does the scanning methodology incorporate a lot of user-facing controls to tailor things, it also incorporates logical safeguards in the scan process itself, so that as the scan is incrementally enumerating devices in the network, it can adapt on the fly to sensitive devices like those OT and ICS systems, or even your typical printer found in the IT environment. Sometimes does not like to be scanned with certain tools. And the passive discovery as an extension of that is the ability to either supplement that active scanning window between your active scans to keep more of a real-time data flow coming into the console, or alternatively for environments where active scanning is just not going to be authorized to be performed, there's still a way to pull in that data and have it fingerprinted through the same fingerprinting process the active scan uses, just opportunistically pulling that traffic off the wire. And all of this comes back to the approach that we take is leveraging a small software binary we call an explorer, gets deployed into the network. So one point of presence in a network segment, various subnets, to enumerate and discover that and actually perform all of these functions, both the active scanning and the passive discovery element. And not to belabor the point, but again, the reason that we take this combined approach is because no single approach here can actually achieve these goals on its own. So passive traffic sampling in particular has visibility gaps typically tied to things like complexity of deployment, because basically the complexity of the deployment, oftentimes requiring hardware, means that you get a good visibility into your north-south traffic, but not so much on the east-west side. And then fundamentally, something has to move across the wire and be observed by that solution for it to highlight that it's there. So API integrations, as we discussed, provide a lot of great contextual data as well, but are going to miss those unmanaged assets just by the nature of the solution. And the active unauthenticated scan is where we fill all of those gaps and actually get the highest level of detail across the board through this discovery mechanism. But then, of course, there are going to be the considerations where we need to bring in that contextual data so we can start to assess their security and coverage gaps as well. So again, the combined approach really becomes the only way to achieve this full visibility that we're aiming for. And I mentioned fingerprinting a number of times here, so I wanted to bring up some examples that showcase exactly what we mean when we're talking about fingerprinting. Going back to some of those vulnerability scan platforms, their primary function, of course, is not necessarily to fingerprint a device. They're really about enumerating vulnerabilities and CVEs. But that being said, they go into OS detection a little bit, but oftentimes what you'll see is you'll have the net result of found this thing. It's a Linux device. Might have some OS information, might have some kernel version information, but that's a broad spectrum of devices. That could be anything from your Amazon Echo Dot all the way up to your critical database server with all of your high value information being stored on it and anything in between. So where runZero is coming in again is to provide that fidelity in the fingerprinting so you can actually see precisely what this device is and the function that it is performing or maybe not supposed to be performing on the network. So that Linux device is in fact a TrendNet IP camera. This is a actual specific iteration of a Chromecast media server. And then you also have the problem where oftentimes, maybe not often, that might not be fair, but many times this fingerprinting is just going to be wrong flat out. So identifying something, for example, as a printer when it is in fact a Schneider electric power device, that kind of information, I mean, if you're making decisions based on this, then understanding that those are two very different devices that probably should be in different areas of the network and performing very different functions is going to be critical in making those informed decisions about your remediation strategy and your security posture. So with that, we're going to take a look at what all of this looks like in action. And I think as we transition into the demo, we have another poll for the audience to answer, which would be much appreciated. So now this is the runZero console. So this is where we collect all of the information together about that inventory and find all of these assets. So one of the things that we're going to do initially from the outset is start to kind of assess what is in the environment here, taking a look at specifically some of those maybe unmanaged devices and take a look at some of the fingerprinting information that runZero is able to provide. So I'm just going to expand this operating systems widget here into a larger view. And with this is going to give us a report that breaks down basically all of the most seen operating systems in the environment and the least seen on the other side as well. And it's really the least seen in this case that we're most interested in. Most seen is probably not going to be too surprising. But over here, we see a number of things. For example, we have our building management system was picked up here with this EBMGR operating system. We have some other things like this PMX30. This is an embedded touchscreen device. So again, one of those things that is probably not being paid attention to by almost anybody, but could be something that is very worthwhile to know exactly where it's connected and if it's properly segmented off from things. And then getting into a little bit more detail here, we can take something like this TP-Link device, a consumer router OS that most likely has no valid business case on the network whatsoever, and start to look at how we bring back this fingerprinting data. Again, really tying this back to what is the actual device, what are the hardware components here. So even with an unauthenticated scan done the right way, then this is going to provide a lot of valuable information about what this device is. And I think this example is particularly relevant because now you have a device that can not only obfuscate other devices through NAT, it's plugged into your network, it has Wi-Fi presumably, so now that's another connection method that could be accessed. And in this case, it's even enabled with LTE. So yet again, another way that you could be bridging from the public internet even into your internal network. Now to call out another example, and this one kind of getting back to that idea of having accurate fingerprinting data available, we can pull up a Ethernet to serial converter here. And not to pick on any vendor in particular, but when this was scanned with the vuln management solution, it was identified as a Juniper Screen OS device. So in this case, this is what you would be working with if you did not have another means of validating and verifying with an accurate inventory that this is in fact this Lantronix device. And the same thing that feeds this fingerprint is what we can use to actually validate and verify that that device is in fact what we say it is, because that fingerprint is based on a number of data points here, not the least of which is data extracted from the web server, where we even capture a screenshot that pretty clearly shows what this is, but even extracting SNMP data out of this on public and private community strings that point to this device, as well as ARP information and even the specific, I believe, telnet implementation that is on these devices. So those are all the data points, well, some of the data points that actually feed into the fingerprinting engine that runZero provides. And that is how we give you this kind of accurate view of exactly what is on the network and what these devices are. Now, when it comes to actually starting to use this information to your advantage and assess risk that's in the environment, this is where we can start to use the queries and get into some of the detail around what is potentially exposed out there on the public internet. So for example, we can query against any of the devices in this asset inventory that would have a public IP address associated to them, and even search for any number of specific protocols like remote access protocols. So in this sense, this is really tying in closely to that binding operational directive 2302, finding out where you have exposed public services and remote access. But just that quickly, we can drill down from the thousands of devices we had in the asset inventory to just a few of these here. And if we needed to kind of triage this and prioritize it even a little bit more, then we could go ahead and search for any of these that might have end-of-life operating systems, such that we know that those are the first ones to remediate. And kind of taking a look at the view that we have here, again, we see that the operating system end of life. We know that this is running RDP, has a public IP address. In this case, an interesting example, because we also have a v6 address. And if we take a closer look at this particular asset, again, to one of the points that HD was making, all of these services are available on this v6 address, whereas we don't really see any on the v4 space. So an oversight, a misconfiguration perhaps, but something that could definitely be exploited to an attacker's advantage and introducing risk into the environment at the very least. And the other thing that we have here is, now that we've identified these devices, we have that ownership tracking. So you know exactly who to reach out to so that you can have these things taken care of and remediated in a timely fashion, whether that's exporting data directly from the console or just linking this over to the responsible party so that they have all of this information at hand as well. An extension of that we can kind of take a look at, looking into the network segmentation a little bit now, is we can do something like search for all of those multi-home devices. And we could even refine this to some of those fun culprits that we see, like the printers out there. And again, very quickly identify where we have these kind of unmanaged assets that are bridging across networks. So we see that these are connected on multiple interfaces, or they have multiple IPs assigned to them. Again, ownership information over here. And if we wanted to extend this into more of a visual component, we could actually move into some of the reporting functionality that we have here. And among those is going to be a report dedicated to showcasing where those network bridges exist. And in this case, it's going to bring up everything by default. But again, using that query language, we can kind of define areas of interest that we want to take a look at. So in this case, we could target, again, some of those IoT devices, getting into another regulatory or compliance initiative where users are going to have to be able to account for their IoT environment by, I believe, the end of August this year. But in any case, we can sort of suss some of these video-enabled devices out. And correct a typo in my query language loop there. And very quickly, we can see that, yeah, right here, we have multiple devices that are actually bridging not only from the WAN to an internal subnet, but then two that even allow potential traffic forwarding from this subnet into yet another one. So validating that segmentation, finding where these multi-home devices live and what networks they're connected to is quite simple and easy with this. Another aspect where we can start to validate that macro segmentation that we might be interested in looking at, especially to enforce that zero trust architecture, is utilizing the asset route pathing report that we have here. So the example provided, or we pick any two endpoints in the inventory rather, that we've collected, we can start to run a trace against those and assess whether these have any potential routes that they can communicate with each other over, and what those intervening hops are. So in this case, we can see that these two devices can in fact communicate, and here's all the potential ways that they could work their way through the network to do exactly that. So if you're really trying to lock down that segmentation and validate, useful tool to be able to identify where those controls can be implemented and anything that's working its way around those controls. And as far as that goes, I think we have another poll as far as responding to new threats that are being targeting the environment. Now, one of the ways that runZero can absolutely help with responding to these this flurry of new vulnerabilities in 0 days is through what we term the rapid response program. So this is where our R&D department goes out, finds ways to detect devices that are impacted by these vulnerabilities, these new 0 days, and then publishes not only an article and a blog post about this, but a query that allows users to rapidly identify where these exist in the environment. And interestingly enough, we have some of these access control devices right up here at the top of the list. But what this looks like in the platform is these are pre-built queries that are already in the ready to use out of the box. You don't have to rescan the environment. We've already collected all of this data. We're just looking at it in a slightly new way. So we can leverage these pre-built rapid response queries to identify where these devices exist and very quickly track those down. And it doesn't even have to specifically be things like 0 days, but if we're looking for potential suspicious services or potential misconfigurations, we can build our own queries to identify those. So in that case, we could do something like utilize the query builder that we have here. And in this case, it's going to give us all of the options for the keywords as part of those attributes that we're picking up. And in this case, we can even start to type in here and get suggestions just like the main query bar. And so we might want to look for things where we have a protocol that contains a value like SSH, and we can pop that in and then add another rule and look for anything where this is not on a standard port. So we would say that the port is not equal to, and of course, put in 22. And then running that query from that query builder, you now have the ability to identify any of those services that are running, and you can save this off into the query library to use for future alerts, or even track these on the dashboard, or define a goal around this if this is something that needs to be addressed in the environment. Another thing that we could do here regarding that query builder to kind of help users get adapted to the query language is actually search for things or use the text editor. So if we wanted to take a more complex query like this one right here, then we can bring that into the query builder. It breaks it out very nicely so we can see exactly what's going on here. And we can make modifications to this not only in the drop-down menu, but using the text editor here, we can just kind of adapt some of this if we want to refine or target into very specific elements of this. And in addition to the native discovery around vulnerabilities that runZero brings to bear, of course, again, through those API integrations, we're bringing in the data set from your other vulnerability management platforms. So in that case, we're going to be able to correlate all of that information together across the environment and specifically highlight all of the assets with that granular fingerprinting that these CVEs actually affect. This is another example of a rapid response log4j that was published. So this is part of the native detection here, but we could just as easily get into this area and start to run queries against sources that are reported via our other vuln management platform, and even bring in the data set from those, such as the plugins from Tenable here. And again, all of this then becomes searchable within the platform. So if we wanted to leverage any of these data points, such as exploits being available, we can click through right on that. We could populate a query and we could pull back all of those CVEs impacting those assets where we do have those exploits available. All right, and I think we mentioned alerting, so I just want to kind of tie this back again to the dashboard. Using that query language, using the things there, you don't have to necessarily go looking for all of this stuff. Once you have any of those queries, such as those pre-built rapid response queries or any of the other provided queries in the platform, you can track those over time as insights. One example of this being those security controlled coverage gaps. We want to be able to find all of our endpoints that are missing a CrowdStrike agent. By extension, you could look for ones that have misconfigured CrowdStrike agents and get those taken care of as well. But at the very least, finding where you have those controls coverage gaps, getting those endpoints kind of pulled in, or if they don't belong on the network, booting them off the network. And then another aspect of this would be utilizing things like goal tracking to be able to do things like look for devices that might be on the National Defense Authorization Act prohibited vendor list. We can track that over time, eliminate those from the environment, or even take something like a access of remote access like SSH, where we want to move this onto a more secure authentication method through public key authentication, eliminating any kind of passwords in the environment. So these goals allow you to define a target objective, what percentage of this is acceptable to you in your environment, and then also tie that to a timeline, and over time track your progress to that. Generating alerts if this goal ever lapses in the future. And those alerts, speaking of those can of course be pinned directly into the console itself, where we can track those. But then we also have different notification channels that can be leveraged. So you can contact the responsible parties through email. You can send webhooks out so that your collaboration platform has these alerts populated in it, or generate a ticket in a service desk, for example. We even kick off an automated workflow using a SOAR platform just based on the detection capability that's built into runZero here. And with that, I'm going to hand it back to Pete to talk about how runZero helps satisfy compliance and zero trust requirements.
Thank you, Derek. I think we also have another, there we go, poll question. Excuse me for the loud noise in the background. So yeah, now that you've seen all of the capabilities and the enormous amount of data that's at your fingertips when you use runZero, it's never been easier to become compliant with all of the directives and compliance reporting that's required in today's world. So if you are behind, Derek alluded to many of the compliance and the reports that everybody is bound to, but if you're still behind on M2404, which is identifying all the IT or the OT and the IoT devices in your network, you still have time. runZero can help you get there, and runZero can help you get there with the various attribution of asset identification, asset description, categorization, owners, points of contact, software and firmware versions. All of these attributions are easily at your fingertips when you're using runZero, and it's not having to go out and run new scans with it. It's all at your fingertips, as Derek mentioned, through the use of queries and just the capabilities to draw that information out to be able to generate reports for your compliance endeavors. And not only that, runZero can help you satisfy, and you can move to the next slide, please, with all of the asset visibility regulations for federal agencies. And when you think of FISMA, the very first requirement with FISMA is asset discovery, visibility. And obviously, based on what you heard here today, runZero can certainly help with that. And Derek also alluded to BOD 2302 when it comes to exposed management interfaces, as well as NIST 800-2013, again, pointing back to OT devices. runZero can quickly and safely enumerate all of your OT devices, and all of the same information, and you can go to the next slide, support all of your zero trust initiatives as well. When it comes to the pillars for devices and networks and visibility, runZero can support all of those initiatives as well without having to crack open a new tool and a new device. It's all at your fingertips, again, utilizing the tools and capabilities within runZero. And with that, I'd like to go into resources and bring up our last polling question for the day. And you can go to the next slide as everyone's looking at that next polling. And so, helpful resources from runZero. runZero does offer a free 21-day trial where you're able to kick the tires, and you can go to runzero.com/try. And you're able to utilize runZero, all of the integrations, everything it would be in a commercially deployed environment. Join us tomorrow for the runZero Hour. Again, Brianna Chuck from Gray Noise will be joining HD and the team. So please join us there, runZero.com, about /events / HD alluded to the research report that was recently introduced back at RSA a few weeks ago. If you'd like to download that report, please go to runZero.com /research report /. Also, you can go to the runZero.com to get the latest zero trust solution brief, which is very informative. And lastly, for those who are going to TechNet Cyber, please join us at booth 2407. Derek and Jim will both be there and would love to see you. And if for any reason you want to reach out to runZero, provide feedback, schedule a demo, please get in touch with us at runZero.com /contact#us. And with that, I would like to thank everybody for your time today, and Godspeed. Lauren?
Thank you so much, Pete. Yeah, we'll move into our Q&A portion of the webinar since we had a few questions come in during that time. The first question is, what types of fingerprinting techniques does runZero employ to provide more accurate, detailed information about devices?
I can jump in for that. So we use everything. I like to joke that, we eat the whole buffalo. So we try to send the least amount of traffic or parse the least amount of network traffic that we can and still provide the most amount of value. So that means even a single TCP SYN packet that we'll send to port 22 of a Linux server. That one packet will elicit a response with a SYN and ACK flag set. It'll also have the TCP MSS. From there, we can figure out the window size, compare that to the outlier, or sorry, the multiplier. And effectively, we can reverse engineer the exact kernel version and the exact OS and Linux distribution just from the SYN-ACK reply combined with the stage banner. So that's just one example. Jared, do you have any other ones offhand?
No, sorry, I can't think of any at the moment.
Okay, yeah, no worries. We do a lot of stuff that's device specific. So for the Lantronix device that Derek was showing off earlier, we'll send a device specific discovery protocol really early on in the discovery process saying, are you a Lantronix device? If so, give us your very detailed data. And then as we continue doing the rest of the fingerprinting process, we can zig and zag to avoid some of the traps with that device being fragile. So for example, those devices are often implanted into weighing machines, scales, medical equipment. And if you connect to one of the TCP ports on that device before it's in a certain state, it'll actually just reload and crash and die and just doesn't work. And you have to wait 30 seconds and it comes back up again. In the meantime, there's a patient in the OR, there's a lift gate that's stuck, there's a bridge that's stuck up, right? So you don't want to be in a situation where you're actually causing physical harm by running a network discovery. And that's why runZero is very careful about that early fingerprinting and being able to work around these fragile devices very carefully.
Great, thank you so much. The next question is, how is runZero able to identify devices vulnerable to 0 days without rescanning?
Yeah, I can address that one. So basically, it kind of comes back to the idea that HD was talking about with collecting all of those various attributes and data points. So we're always collecting that information, eating the whole buffalo, as it were, and pulling that data in. When it comes to identifying the new vulnerabilities, such as 0 days, we're just taking the attributes that already exist in the asset itself and running a query against those to parse out the ones that are indicative of a potential vulnerability there, whether that's a specific version of a service or a software component, or oftentimes in the case of OT or IoT, where really you have embedded firmware, even a particular model or of device.
Great, thank you so much. And it looks like we have time for one more question. So what types of integrations does runZero offer? How does it integrate with my existing tech stack?
Sure. So for that, we integrate with all kinds of things. Your IAM, so connecting to your Active Directory, your LDAP, your Azure AD, Entra ID. We can bring in data about users and groups and then use that to assign ownership and track who actually owns a particular device. We connect to all of your EDR platforms. So if you've got SentinelOne, CrowdStrike, Defender, we'll go bring data in about those endpoints and say, does this device have this endpoint installed? And if the endpoint agent provides useful details like BIOS, serial number, things like that, that's also visible in runZero. So it makes it very easy to say, okay, now that I've imported my CrowdStrike data, I can now do an even deeper scan and say, find me everything with that, where I've got this model of Dell Latitude, but it's out of date on the BIOS. That's all information you can pull out of it. And we go, of course, much further. You can bring data in from your vulnerability management solutions, so your vulnerability scan overlays on top of it. You can actually bring in data from almost anything. We've got a custom SDK that allows you to bring in arbitrary data and stack it on top of existing runZero assets, as well as the REST API. So you can just tack arbitrary attributes onto an asset as well. So you have a homegrown CMDB internally or some other security tooling you've already built. You can either pull the runZero data out very easily in JSON or CSON or CSV format, or you can bring it all back into runZero and overlay it on the same spot. So we've got a very open ecosystem, and it's very simple to play with. It's kind of really straightforward. You can either use existing integrations or quickly build your own with our SDK and open APIs.
That's great. Thank you so much to our speakers, HD, Pete, and Derek, for being with us this afternoon, and for all of the participants who joined us today.